You know that feeling when you use an app and it just works? It's smooth, it's fast, it feels like it reads your mind. Well, behind every single piece of great software like that, there's an invisible plan, a secret blueprint that makes sure every little piece clicks together perfectly. So let's dive in and figure out what that blueprint is all about.
But first, let's start with a question I think we've all asked at some point, especially if you've ever been near a tech project. Why on earth do so many of them just completely go off the rails?
I mean, we've all seen this story play out, right? The budget just balloons, deadlines become a joke, and what you get at the end is full of bugs. Or, even worse, it's packed with features that nobody even wanted in the first place. It is a total recipe for disaster and, you guessed it, a lot of unhappy users.
Now here's the thing, the issue is almost never a lack of talent. These teams are usually full of brilliant people. No, the chaos usually comes from something much simpler. They didn't have a clear plan that everyone agreed on. It's like everyone was building their own separate tower and they only realized they didn't match up when it was time to put the roof on.
And this is where our hero finally enters the picture. It's officially called a Software Requirements Specification, or SRS for short. Just think of it as the master document. It's the one single source of truth that lays out exactly what the software has to do, and just as importantly, how well it has to do it.
So, the absolute best way to think about an SRS isn't as some boring stack of paperwork. No way. Think of it as an architect's blueprint for building a house. I mean, you would never try to build a skyscraper without a super detailed plan, right? So why would we ever try to build complex software without one? Let's stick with this blueprint idea as we go.
All right, first things first. Every good blueprint starts with a solid foundation. This is where we define the big why. What does the homeowner, or in our world, the user, actually need? And what are the ground rules and constraints we have to play by?
Now, this right here shows a really critical difference. On the left, you've got the business requirement. That's what the user experiences. In this example, they need to approve a big money transfer by taking a quick selfie to prove they're a real live person. Pretty simple. But on the right, you have the non-business requirements. These are the technical rules happening behind the scenes. The system has to be fast, under 5 seconds, and it has to be efficient, keeping that photo under 2 megabytes. See the difference? One is the what, the other is the how well.
Okay, so our foundation is poured. Now it's time to actually design the structure. This is the what of our master plan. This is the part where the architect actually draws out the floor plans, showing where all the rooms go and how they're all going to connect.
In the software world, we call this the high-level architecture. It's like the 30,000-foot view of the whole project. It's a map that shows all the major parts of our digital house and how they're all supposed to talk to each other. This is the big picture that stops you from accidentally putting the kitchen where the garage is supposed to be.
And this architecture, it really stands on 4 key pillars. Deployment is basically where the house gets built, on what servers. The network policy sets the rules for who can go into which rooms. The security policy is all the locks on the doors and windows to keep it safe. And the CI/CD process, that's the automated factory line that builds and updates the house quickly and reliably.
You know, before you build a house, you want to see what it's going to look like, right? Of course. And that's exactly what mock-ups are for. They're the visual sketches, the artist's drawings that make all those abstract plans feel real. Everyone can look at it, point to it, and agree on it long before any expensive coding starts.
And just like a real house needs closets and pantries and places to put things, our software needs a data model. This is the blueprint for the database. It's our digital storage system. It defines exactly what information we're keeping and how it's all organized so we can find it later.
Okay, we've got the foundation and the main structure. Now for the really nitty-gritty part, connecting all the details. This is where the blueprint gets super specific, laying out the how for the builders. We're talking about the instructions for the plumbing, the electrical wiring, all the internal systems that make the house actually function. In software, we call these instructions flows. And honestly, the best way to think about a flow is like a very detailed recipe in a cookbook. If a user clicks the submit button, the flow is the recipe that tells the system every single step it needs to take in the right order to get the job done correctly.
And you know, a good recipe doesn't just assume everything will go perfectly. As you can see here, a great blueprint plans for problems. It defines the happy case for when a user does everything right, but it also plans for a timeout case if a server gets stuck, or for what happens when a user just plain forgets to fill out a box. You gotta plan for reality, not just perfection.
So when different parts of our system need to team up, we use something called a sequence diagram. This is basically the choreography for a dance. It shows the exact back-and-forth conversation that has to happen between different services to complete a task. It's like, okay, you do this, then I'll do that, then you send this back to me.
But how do they actually talk to each other? Well, they use an API, which stands for Application Programming Interface. Just think of an API as a really strict contract. It's a set of rules and a very specific language that two different systems agree to use so they can communicate without any confusion. It's like a universal translator that makes sure everybody is on the same page.
We are almost there. The house is fully designed, all the details are mapped out. The very last step is the final inspection. This is all about preparing for any what-ifs and running a ton of quality checks to make sure our building is strong, safe, and ready to go.
And a huge part of this is planning for change. You have to ask the tough questions up front, like what existing parts of our app is this new feature going to affect? And what other tools are we depending on? For example, do we need to rely on an outside service for something like OCR to read text from a photo? Figuring out these ripple effects now saves you from massive headaches down the road. And of course, we have to test our work. The test strategy is the official game plan for that. It's how we're going to kick the tires, stress test the walls, and check all the pipes to make absolutely sure everything was built the way we designed it and that it's strong enough to last. And here are a few of the common ways we do that. Sure, stress tests and load tests are great for seeing how things hold up under pressure, but look closely. Manual tests, where a real person clicks through everything, and unit tests, which are automated checks the developers write. Those are mandatory. They are the absolute, non-negotiable foundation of a quality product.
So if you remember one thing from all this, let it be this. An SRS, our blueprint, is so much more than a technical doc. At its heart, it is a communication tool. Its entire reason for being is to get the client, the project manager, the designer, and the developer all looking at the exact same plan on the exact same page so they all build the exact same house.
Now, some people might argue that all this planning just slows you down in today's fast-paced world. But this quote here just nails the rebuttal. To be truly agile, to move really fast, you have to be stable first. A good plan isn't a barrier that gets in the way of speed, it's the solid launch pad that makes speed possible.
And that kind of leaves us with one last thing to think about. In a world that is obsessed with moving faster and faster, is it possible that the art of slowing down just enough to create a thoughtful plan, a really clear blueprint, is actually more important now than it has ever been before?